Okay, excellent. Okay, so let's touch base a little bit. So you guys know you have another exam that is going to be popping up later today. Yes, sir. The practice exam is already out for that exam. Yes, the practice exam has been up since Tuesday. So, yes. I know there is about 2 people who had some issues with the second exam. What I need you guys to do is to stay after today. We need to discuss our solutions. One of you guys, well, actually both of you guys, one text me, one email me. Okay, if there's anybody else, you need to stay after. We'll discuss that. Later, I'm still in the process of putting your grades up, but you guys have an idea how well you did on the exam, right? So at this point, you should be thinking about test corrections, if you know. So you want to be thinking about test corrections, especially because you should have a good idea how you did on the second exam, because there's only a few short answer questions, and you should have a good idea how you did on the first exam. I'm looking at your first exam and I'm like, and they expect to pass this class, right? So seriously, I told you from day one that I should say not I, this class is the key to your degree, right? You have to pass this class to have your degree. For those are in Avenel, and then some of you guys that are in Kalinga, right? Okay, so you want to make sure that you're going to be passing this degree, right? So I'm in the process of fixing all of the CHEM-101 exam assignments, so they'll be opening up, because I've noticed that some of you guys have not been able to complete assignments for some reason, right? Now, whose problem is that? Okay, so you want to make sure that you complete all those assignments. You know, you don't get a free buy because, you know, I'm this close to my degree, right? That means you work that much harder to finish off. You don't tap out. I know you tapped out of high school, but you don't tap out of college. You want that degree, okay? So you want to make sure that you're passing this class. I have to give her a list of students that I may be dropping this week, right? If you show me no effort, tomorrow is the day I drop. If I don't see any changes that happens between today and tomorrow, I'm dropping your ass real quick, right? Because they don't want you guys to have an F on your transcripts because it looks bad for the program. Okay? Are we clear? Are we clear? I only heard one person say yeah. Okay. So, are you guys ready for some chemistry? Yes, ma'am. I will not be here tomorrow. You can, yeah, you guys, hold on. Let me see. Mrs. Inez, are you going to be here tomorrow? On Monday. Okay, so yes, there will be no class because I know you guys transferred everything, but you guys went to class on Monday, right? Most of you guys went to class on Monday, right? Okay, I'm not going to say all of you because I know that there are some faces that I did not. I'm like, what the hell is that? You know, although I'm saying that anyway because I don't see any of your faces, but you know. Yeah, okay, I'll go talk to Mrs. Gornick, but as of right now, you've done your time with me for Monday. We met online on Monday. You made that choice to show up, you met. So you guys are good with me. So you don't have to come for my class. I will confirm it with Mrs. Gornick after this, after lecture. Yes, ma'am. The parity, it has to be 2 to 3 minutes. No more than 3 minutes. Yes, ma'am. What was that? No. No. It's 2,000 words. Okay, you're off by a factor of 10. If you guys read it, it actually tells you exactly what I'm asking for, right? Okay, so it's 2,000 words, which is about anywhere from 5 to 8 pages long. Yeah, but you have groups of 6 and 7. So what are you complaining about? Okay, so let me repeat the question. Let me repeat the question so people understand what I'm. Okay, so the question was, if it's me and Jaime are in the same group, right? Think about what you're saying. Me and Jaime are in the same group. So that means that we can have the same paper. Now, this is the group project, right? That means that you're turning in one paper, right? I am not reading 39, 40 papers. One of your teammates. You guys decide who turns it in, and they turn it in, and it will populate. It will populate for all of you as being turned in. If one of you guys turn it in, it populates for everyone. Okay. That's the same thing with your parody. You're going to turn in your parody or the link to your parody. One person turns it in, it's going to populate for everyone. Okay. And then your page, I'll see your page, you'll get 1 grade. Okay. So you're getting a page as a group for your parody, for your page, and then also for your presentation. So that's all going to be the same grade. So, you know, Jaime won't get a C and you get an A. You all get C's, right? So you understand group means you're doing this as a group. Okay, good. Any other questions? Good questions. We need to clarify that, you know, I can see the haze behind it. Eric, yes. I expect an A. No, it's actually, if you take a look on the page, it gives you the format. It's a scientific format. MLA is semi close to it, but it's not quite it. If you take a look, it gives you specific examples, okay? Yes, I will be opening up CHEM-101. I have to contact CHEM-101 because they're like, you haven't paid your bill yet, right? So we're trying to get that under control. So I can't see what you guys actually done. I'm guessing, right? I'm taking a guess, you know, of what they've actually done. So, so we have to pay our bills so that I can actually see your grade. Yes. The group project, it can be double spaced. It doesn't need to be double spaced. If you want to make it double spaced, that's fine. But still, it's going to end up being the same number word count, right? That's why I do is word count rather than pages. Next question. Yes. So the question is, the paper, the project, and the parody has to be based upon the topic that you have. Yes. No, it's about your topic. Yes, sir. That is correct. Can you use videos in your presentation? I love that question. Okay, so I am not opposed to using videos in your presentation, but you got to remember you have a 20-minute presentation. Now, if you give me 20 minutes of Tyler DeWitt talking, right? I'm giving you 0 for your presentation because you did no talking. So there's a balance, right? If you give me like a minute or so of something that you wanted to show me, right? And if it's a video that you did, right? Oh, that's even better, right? So, but if it's somebody else doing the work for you, hell no, you're not gonna, you can do it, but you take the risk of getting a 0, right? You guys are adults, come on now. Yes, you are. You're in this class, you're an adult. As soon as you signed up for this class, as a college student, you're considered an adult. I will be sending, you guys will get a link. And so as soon as you get that link, you want to start clicking because it's first come, first serve. You want to click the time that you want. The way it's going to be set up, and I'm also going to tell Mrs. Gornick this. So on Wednesday, Thursday, and Friday, right? I don't expect to see you guys, right? So you guys can stay at home and do this because your presentation, you guys are going to do online so that everybody can see. Okay, so make sure you're at a place that has stable internet connection. Fatima, where are you? Make sure you're at a place where you have a stable internet connection. Okay, so yes, ma'am. That's right. Well, no. Let me clarify. All your groups has to be online together, right? You could be in, like we did this before. I had a student that was in Japan. I had one that was, so if they can do it, you guys can do it, right? So you guys are just giving your presentation as a group. So your screen will pop up when you're talking. The other person's screen will pop up when they're talking. But one of you guys have to control the slides, right? So they'll be sharing their screen and you'll be doing the talking, okay? Okay, so that's how your presentation is going to work. Now your parody is going to be embedded, should be embedded in your presentation. It should be the last thing that we talk about. So first you're going to do your presentation. you're going to get us kind of warmed up. Yeah, that's the goal, right? You don't, okay, so here's my rule about this. You don't have to show up, right? But here's the benefit to showing up, right? Let me give you guys, settle down. The benefit to showing up to your classmates and other classmates, charities and presentations, the benefit is that you get to see what they did, right? So let's say you signed up for a later date and you see that they got ripped apart by me, and that does happen sometimes. Believe me, I can get very mean. Yes. Oh, very nasty. Yes. Yeah, okay. Yes. See, that's the next part that I'm getting to, right? So the rule of thumb is you guys have a question and answer session, right? 5 minutes about question and answer. You do your 20-minute presentation. I get 5 minutes of questions. Now, my rule is that if your classmates and your peers show up and they ask you questions about what you've done, right? Then I don't ask any questions. Now, if they don't show up, I get to ask the questions. And like Miss Inez says, they can be really mean questions at points. It's about what we're talking about, and you should know it because we've gone over it and you just presented on it, right? But I can get mean enough to embarrass you at points. I have no quarrels about that because that's the real world. That's the way it works. You give a shitty presentation, you're gonna get ripped apart, I promise you, right? Yes, I've had a few people cry during presentations, right? So it's not surprising. But I also have people that have given, immaculate presentations. The majority of the students, they do a good job. They put the time into it. You put the time into it, it shows. If you give me BS, it shows. And I can, as she says, I smell BS. It's all over my shoe, right? So I smell it immediately, and I will call you out on it because you guys are at this level. You should be performing at a college level. You are not high school students, you are college students. Is that clear? And that goes for Kalinga and NDC too. You guys are college students, right? Okay, there was another question. Okay, repeat that again. Okay, again, you're not doing pages, you're doing word count. Word cited does not count as word count. That's not being included as your word count. I don't include that in my word count when I take a chunk of your paper, right? That's fluff. But I'm telling you this, you need to have at least 5 things cited, right? So if you don't have more than 5 things cited, that's a problem, right? Where is lab 6 in modules? I don't know. We'll see what happens. Okay, any other questions? Okay. No. I will actually send this out for you. It's actually, there's one available. I think it's under peer review. If you go under peer review, there's a little, if you click on it, there is a PDF. That PDF actually tells you what I'm looking for. Now, I've made some modifications, and I did it just especially for you guys. So it may be modified by the time you get up there, but it'll give you an idea. Okay, any other questions? It's real simple. You get to your team members, right? So you want to sit there and you do it by yourself, right? When you're all by yourself, you give them an A, B, C, or D, or F, depending on the work that they put in, right? So if they didn't do anything, they didn't show up, they kept promising to show up and they never showed, what are you going to give them? An F, right? So if they came and they did only half the stuff that they said they were going to do, what are you going to give them? A D or a C, right? And then if they were great and they did everything that they said they were going to do and they were always there from the beginning to the end, an A. It's real simple, right? Not too hard. So then what I do, I take your grade into consideration, but I also take into consideration, because you can kind of see when somebody steps up, and then when other cases where other people just kind of lived off the harvest of the land, right? So basically took advantage of all the people that they were working with. They were really good students. So yeah, I can kind of see that as well. So then I take in consideration, because I know that you guys have known each other since you guys were in 2nd grade, and you're the besties of besties, and she's my best friend, well, there's no best friends when it comes to getting the job done, right? Okay. Any other questions? What is top 6? Excellent. So every exam, what happens is I take the top 6 students of all my classes, and they get extra credit points added on to each of their exams. You don't see this until the very end, because I have a tendency of students that, oh God, I'm doing so much better than I really am, right? And then they get to the final, because they've had all those extra credit points that they've calculated already into their score. They get to the final and then they blow their final. Instead of getting that A that they should have got, they end up getting a C or a B, because they were like, well, I had all these extra credit points. So that's what that is. Yeah, that is partially why you guys can't calculate your scores, because there's a tendency that you guys do this self-calculation, right? And then you're like, oh, I want to get that C. And then you're off by 20 points, right? And then you don't end up with that C, okay? So I wait and wait and wait, and then I put them all up at once. They start showing up. Okay, so let's get started. We talked about the mole, right? So a mole is what again? Help me out. Avogadro's law or Avogadro's number? Avogadro's number. Remember, I couldn't spell Avogadro? Right. Okay, so Avogadro's number, and it's 6.022 times 10 to the 23rd. Okay, so one way of remembering that is to go get a tattoo and tattoo it on your chest. You'll never forget it after you do that. Every time you touch it, you'll remember that pain that you had of chemistry and also that tattoo, right? Okay, another way to remember it is just remember 6.022 times 10 to the 23rd. Okay? Okay, so how do I use Avogadro's number? Why do I want to use it? Okay, and what, again, what is the significance of calculating the moles? Oh, yeah, it goes back to the molar mass. And what is the molar mass that you brought it up? What is molar mass, since she brought it up? Margarita is just throwing things at you. She's like, I'm going to keep throwing stuff until it sticks, and something is going to stick. It is the weight of the atom, okay? So the molar mass is the weight of the atom, and we use the molar mass to convert from grams to moles, right? So Avogadro's number is just the way of converting from grams, well, moles. So the reason why we use moles, why do we use dozen? Does anybody know why you use a dozen? Why is a dozen 12? Say it again. Say it louder so everybody can hear you. Okay, he said to make it easier, right? And that's the reason why we use dozen. Why do you think we use a mole? To make it easier, right? Because rather than having 6.022 times 10 to the 23rd and having to write out that long, long number, you could just say 1 mole, right? Isn't that a lot easier than having 6.022 times 10 to the 23rd? Okay, so now I have a question for you. I want you to think really, really hard on this. I think I've asked you this question. I've asked it before. I forget, there's so many different classes. So if you have a mole of pennies or $3 trillion, I guess I did ask you this question before at the very beginning, right? And now see, you came full circle, perfect, right? So you want that mole of pennies, right? Because it's more money. Does that make sense? Okay, because 6.022 times 10 to the 23rd is a whole lot of stuff, right? Okay, good. So how do I use it? Okay, here's an example. A sample consisting of 0.25 moles of ammonia. How many ammonia molecules is this? So where am I going to start at? I'm going to start with what's given, 0.25. Okay, Enrique. Every time I call him Enrique, he's never here. Okay, let's see. Let's go with Jaime. So what am I going to do, Jaime? I started with what's given. I have moles and I want molecules. I'm going to cancel. I'm going to cancel the moles. What am I going to use to cancel the moles? 1 mole is equal to what? Okay, so we know that there's an equivalency. 1 mole is equal to 6.022 times 10 to the 23rd, right? Okay, so I have moles on the bottom because I want to cancel the moles. That's what you're telling me, right, Jaime? And then I'm going to have what on top? You said it just a second ago. You got to remember it. 2 times what? Times 10 to the 23rd. And that's going to be molecules, right? Because we can make it anything we want. It could be girlfriends, it could be wives, it could be husbands, it could be molecules, right? Just like that dozen could be a dozen of anything, right? Okay, so what is my answer? Come on, do the calculations. You guys have your calculators there, right? I can't do everything for you. You want me to whip your butt too? So if they're on the same, they're all up top, it's multiplication. If it's beneath, it'll be division, right? Just like this, right? If I have 4/2, what is that? You have 1 point. Okay, how many sig figs should I have? I should have 2. 1, 2, right? So it's 1.5 times 10 to the, I'm gonna slide this over. Are you sure it's times 10 to the 23rd? Okay, I'm just asking. Gosh. Molecules of NH3. Okay, questions, concerns, Cash? Well, because we're talking about NH3, right? So this is molecules of NH3. Well, it's canceled out here, right? It's canceled out. The moles are, but we want molecules of NH3. Yeah, so it's not canceled out. It's still there. Yeah, that's why we have 1.5 molecules of NH3, right? Because that's what we're looking for. Okay, simple, not too hard. Somebody scare her so she stopped stop her hiccups. Okay, Margarita's already talked to us about molar mass. We know that that is just the molecular mass. So we can calculate our molecular mass. You guys already know how to do that, right? And then we also know, I told you guys our last session that it's based upon carbon, right? carbon 12. So we know that carbon 12 weighs 12 grams per 1 mole. Now, here is the beauty of everything. And when we talk about that mole, right? Let's see. The beauty of it is that that mole is that quantity, right? So a mole is quantity, mass is mass. So if we look at that term, molar mass, we should know that that's what we're going to be using to convert from moles to mass, or from mass to moles. Are you guys with me? Okay. Okay. So calculate the mass of calcium fluoride. So what does calcium fluoride look like? What is the chemical formula for calcium fluoride? Ca, and somebody said F. Are you sure? Do you want to put money on that? It's F2. So, because we know that fluoride has a what charge? A negative charge. And we know that calcium has a just one positive? It's a 2+ charge. So if I have a 2+ and I have one negative, I need two of those one negative to balance it out, right? Yeah, we already knew that from nomenclature, right? Right? If not, you're in a lot of trouble. Okay, so how do I calculate the molar mass of calcium fluoride? Can I just pick numbers out of the air? Where do I find those numbers? Oh, I go to the periodic table. Okay, let's see. Okay, so Ca has a mass of 40.078. So I could probably get away with saying 40. Okay, that's what you're telling me. Okay. Let me see. So I have 40 for Ca, and there's how many Cas do we have? So we have one, so 1 Ca, so 1 times 40, it's 40, right? And then how many fluorides do I have? I have 2 fluorides. So we have 19 times 2. Okay. Okay, so 38 plus 40. And my units are grams per mole. Because grams is mass, right? And a mole is a mole, right? So that's how we get that term molar mass. It's grams per mole. Okay? Questions, concerns? That's the answer. Because, she asked, the question was, why is it easier when you do it with me than when you do it by yourself? Because you have such a cute instructor, it makes it so much easier, right? Yes. What was the question? Bye. Can I what? Can I make it clear? I'll change the background for you, just because I like you. And then I'll move it so you can actually see it. How about that? Okay. So it doesn't matter about the sig figs because these guys are, I should say, what you see on the periodic table can vary from periodic table to periodic table because they're rounded, right? So like for instance, if you take a look at your fluorine up here on your periodic table up there, there's four decimal points out, where another periodic table will just have 19 with no decimals. So that's right. That's right. Yeah. And so we rounded it, so it's going to be insignificant, right? Since we did that rounding. So you don't have to worry about it. So you're never going to use your molar mass for sig figs. You're going to use the original number that you're working with, right? Or a number that you're multiplying by that's in that problem or something. Okay. So you want another? Okay, cool. We can do that. Everybody got this down? Okay, okay. That's because you guys don't take the time to read what they're saying. You have 2 hours. You can't get it done in 2 hours. 30 questions in 2 hours. Okay, okay, okay. Okay, so I got one for you. I got one for you. Okay, so that means that you left it not doing anything too long, right? And it didn't see, like, if you didn't move, if you weren't in front of the camera, then like if you're not there in front of the camera, you didn't see you move or anything like that, it'll kick you out. Okay, calculate the molar mass of mercury 1 phosphate. What was that? Yes, it's exactly the same. It's no different, right? Okay, you guys are talking about mercury 1, right? Okay, I'm just making sure. Okay, so what is the chemical formula for mercury 1 phosphate? So we can start off simple. We can break it down because it takes about just a PO4. What would be the charge on phosphate? 3 negative. And what is the charge on mercury 1? It's 2 plus, right? Because we know that mercury 1 is the only diatomic, right? Okay, so how many mercury 1s am I going to need to balance out? So you're saying, that's right. So I'm going to have Hg6. And then how many phosphates? That's right, PO4, 2. I'm gonna get the periodic table, relax. Ooh, man, a little feisty, aren't they? Okay, why? Is there crazy stuff happening? Okay. Okay, so we have mercury. Okay, so mercury, what? How many mercuries do we have total? We have 6. So we have 6 Hgs. How many phosphorus? How many? Phosphorus? 2. How many oxygens? 8. We're looking up here up top. It's Hg6, PO4 2. How much does mercury weigh? How much? 200. So 200.5. We want to keep that one in this case, right? Because it's like that it's that middle line. So we're going to keep both of those. We're going to 200. Times 6. We're going to keep them both right now. Just relax. I'll explain to you in a second. I promise. What about phosphorus? Okay, phosphorus. Let's click on it because I can't see it. I'm blind. So that's 30.974. Is that really close to 31? It's like 0.03 or 0.026 off. So it's pretty darn close. So that one I'd say we could round up to 31, right? Okay, so we're going to put 31 times 2. And oxygen is going to be 16, and that's 16 times 8, right? I know I'm writing over stuff. I'm going to go to my whiteboard here in a second, I promise. Okay. Okay, is that better? Okay, so the reason why we're keeping the 5, or we could have said 6, the reason why we're keeping the 200.59, right, is because we know we're going to have to add more of them onto it, right? So we can't just round up to 1 because then that'll give us too much. But we're going to be multiplying it by 6. And you said we got what value for that? Okay. So you said 1,203.54. Okay. We have 31 and you said 62. 8. Okay, wait. Let me make sure I did this math right. 8 times 16 is 62. Oh, 31. Okay. Okay. You said 120, 128. So we add them together. And the units, G/mole, grams over moles. Okay, piece of cake. Was that challenging enough for you? No, still too easy? Don't worry about it, we'll make it harder. Okay, you guys ready to move forward? Excellent. Okay, so what is the difference between 1 mole and 6.10 to, well, what? 6.022 times 10 to the 23rd, okay? So they're the same. However, when we talk about 1 mole, right? 1 mole makes reference to that number. And it could be anything that we want it to be. It could be molecules, it could be atoms, it could be electrons, it could be anything. Are we clear? Okay, so then I don't get it. Okay. That's true. Well, they wouldn't even know, they would think you're talking about the animal, the mole, right? Okay, so if you look at this figure here, right? So if you take a look, we have iron, we have mercury, we have copper, right? So these are all 1 mole of material, but they all weigh different in terms of mass. So like for instance, if I have a mole of apples and a mole of grapes, are they gonna weigh the same? Why? Okay, wait. Now, if I have a mole of apples and a mole of grapes, now think what I'm asking you. What was that? Say that again, Haley? Because apples are more heavier than grapes. So the apples are gonna weigh more. So 1 mole of apples is gonna weigh more than 1 mole of grapes, right? Exactly. Okay, so that brings us to what the whole premise is, right? We're working with moles. That is quantity. That's how many we have. Like if we have 5 apples, that's 5 apples. If we have 5 grapes, that's 5 grapes. But we know that 5 apples are gonna weigh more than 5 grapes, right? Because it's not mass, it's quantity, right? Okay, so why is this important to us? Because have you guys ever cooked? Have any of you guys ever cooked a cake? Cooked a cake, bake, I'm sorry, bake, excuse me, baked a cake. Has anybody ever baked a cake from a box? Okay, I would say almost everybody here has baked a cake from a box. Would that be true? Okay, good. So let's talk about making a cake. I like cake. Did I tell you my favorite cake? No, it's not a red velvet cake. No. My favorite cake is a strawberry cake with chocolate frosting with real strawberries put in the middle, in that middle layer, and real strawberries on top. Favorite cake, just so you know. My favorite filling is strawberry and chocolate. Would I accept it? It depends on who it is. You, of course, if it was from you, of course. You know, if it was from you, I don't know. I'd be worried about what's in that cake. I'm just a little concerned there. Now, if you're gonna spike the cake, let me tell you things to spike it with. We'll talk about that later. Anyway, okay. So when you bake a cake from a box, you start off with what? What are the things? What are our ingredients from the box? Okay, wait, slow down. So we got eggs. We got eggs. Okay, we have milk because I like mine to be really rich. And I don't use oil, I use butter because butter makes everything taste better. Strawberry cake. Strawberry cake, yes, strawberry cake, strawberry flavored cake. I do. That is really good, especially with the strawberries. Delicious. Okay, so on the average, you'd say about 3 eggs. Is that right? Would you say 3 eggs? 3 eggs. Okay. Let's see, how much milk? About 1/3 of a cup or a half a cup? 1/4 of a cup of milk. So a stick of butter. Oh, no, I didn't say anything about a diet. Have you seen my gut? Do I look like I'm on a diet? No. And 1 box, right? And that's gonna make, you know what I mean, the box mix. Okay, and that's gonna make 1 cake, right? Is that true? Okay, from your experience, that is true, right? Okay, so now you guys go and weigh the eggs. Did you guys go and weigh the butter? Did you guys go and weigh the box mix? Now we measured the cup of, but that's about it, right? So when we think about a recipe, we're talking about quantity, right? We're not talking about weight. We're talking about quantity because it makes more sense to us to talk about quantity, right? If somebody tells you, oh, I make the greatest sangria in the world, I do, right? And they tell you the ingredients, you write down how many pieces of apples and how you write that stuff down, right? Right? You don't write down, okay, you need 15 pounds of apples and 35 pounds of, and no, it's quantity, right? So it's based upon quantity. When we're talking about a chemical equation, it's based upon quantity. Let's say we have copper 2 nitrate. Reacting with lithium metal. What are going to be my products? What type of reaction is this going to be? You should know it immediately. A single replacement. So who's getting replaced? Who's the old girlfriend and who's the new girlfriend? Lithium is the new girlfriend. That's right. The old girlfriend was Cu. Now remember, wait. So what charge is nitrate? It's a negative. So are you going to replace a negative with positive? Are you going to replace a negative with positive? And I didn't answer it. I didn't ask it twice because you gave me the right answer. Are you going to, okay, so for instance, are you going to replace a girlfriend with a boyfriend? Okay, that's true in real life, I guess. Yes. Okay, so let me repeat. Let me see if I can rephrase this. Okay, I should say that either. I don't know. Oh, okay. Okay, so are you going to replace a car with a bicycle? Okay, so you're going to replace a car with a car, right? Okay, so now this is a negatively charged ion. Are you going to replace a negatively charged ion with something that's going to be positively charged? No. So who's going to be replacing each other? You have a positively charged ion, and this guy can be a positively charged ion. So you're going to go metal for metal, right? Okay, so lithium is going to hook up with nitrogen. I mean, the nitrate. What is the charge on nitrate? It's a negative, just a single negative, right? What is the charge on lithium? It's 1 positive, so it's 1 plus. So they balance each other out perfectly. You said, right? And then copper is going to be all by its lonesome, and it's not going to be charged. Okay, is it balanced? Yes, ma'am. Yes, you would put together a negative and positive. That's what make ionic compounds, right? Things that we've been talking about since the very, very, very beginning, right? Well, girlfriend and girlfriend, right? You're going to replace the old girl for the new girl, right? You're not going to replace the old girl for the new boy, right? Right? So it does look balanced to you? Are you sure? Oh, sorry. That's because I forgot this. How about now? Okay, so we're balanced, right? You agree? Disagree? Okay, so we have a balanced chemical equation. Okay, so now what this is telling us is that for every one, yes, sir. Why did I put the subscripts? It doesn't go away. We're taking into account two of them, right? And so it takes to balance copper, is copper 2, right? That's right. So remember, it's its own person when it's by itself. As soon as it's with copper, it has to be 2, right? There needs 2 of them. So the question was, why did the subscript change from on nitrate on this side and that side? Because we're talking about copper 2. It takes 2 nitrates to balance out that copper 2's charge. Where lithium is only a +1, it only takes 1 nitrate to balance it out. But at the end of the day, it has to be balanced, okay? Okay, so now this tells us that if we have copper 2 nitrate, I'm gonna need, for every 1 copper 2 nitrate, I'm gonna need 2 lithiums to have this reaction to happen in completion. Does that make sense? That's what the equation tells me. So the equation also tells me that for every 1 copper 2 nitrate, I can make 1 copper. For every 1 copper 2 nitrate, I can make 2 lithium nitrates. Okay? You're getting all of that information from this one equation. Does that make sense? Yeah? Good. Okay. So let's see. Let's say I have let's say I have 0.25 moles of lithium. How many copper okay? So how many copper molecules can be made from 0.25 moles of lithium based upon this chemical equation? Can I figure that out? Let's try it out. So if I have 0.25 moles, that's going to be my given. Okay, so if I look at my lithium, I have a 2 in front of it, right? So that tells me that I have, for every 2 moles of lithium, I can make how many moles of copper? What's in front of the copper? Or what's understood to be in front of the copper? 1. So I want to get rid of moles of lithium, 2 moles of lithium, and 1 mole of copper. So that gives me my number of moles of copper. Okay, now molecules. I shouldn't say molecules, I should have said atoms because it's not a molecule, right? So how can I figure out the number of atoms that I'm making? What was that? Multiply by what? Jaime, we talked earlier. Okay, so 6.022 times 10 to the 23rd atoms. And we know that that is 1 mole. Okay, so somebody said it, we can cancel. So this is going to cancel this out. This is going to cancel this out. And we're left with just atoms of copper, Cu. Sorry, I always run out of space. So that equals okay, you said it's going to be what? 3.011. Are you sure? Okay, so you got 7.5. Okay, 7.5275. How many sig figs should I have? 2. So 7.5 22nd. Okay. Okay, piece of cake. So are you guys seeing how you're using dimensional analysis, right? In terms of chemistry, piece of cake, not too hard. Good. Okay, so let's keep moving. Okay, so we're going to keep moving forward. So you can carry out a laboratory reaction that requires 0.0360 mole of barium chloride. How many grams of the compound do you measure out? So we're going from moles to grams of barium chloride. So what do I need to do? Are you okay? I need to convert to what? And what am I going to use? I need to convert from moles to grams. So what am I going to use to convert to moles to grams? First thing I'm going to do is do what? So my given. Oops. Oh. hold on. Zero 0.036. Now, it's moles of what? Barium chloride. So barium chloride, what is the chemical formula for barium chloride? BaCl, Cl2. Okay, Alex. So how do I calculate the mass of barium chloride? Is there an Alex? Is there no Alex? Okay. How do I calculate the mass of barium chloride? You look at from where? Somebody help them out. From the periodic table. Okay, so I go to the periodic table. I find my barium. Barium weighs how much? So how many bariums do we have? We have one. So it weighs 137.33, if I remember correctly, right? Okay, we have one of them, right? Is that right, Alex? Yeah. Okay, so I have my one barium. How many chlorines do I have, Alex? Boy, we got a lot of Alexes in here. Man, I didn't realize that. Wait. How many? Two. So we have two chlorines. Okay, so how much does chlorine weigh? I'm talking to Alex. He's helping me out. Alex was taking a snooze earlier. That's what that was. He has one eye open and one eye is closed. He's doing this. So how much is it? It's how much? Are you sure? How much does it weigh? 7 is the number of what? It's 35. Are you sure it's 35? Somebody want to help him out? It's, let's say, you said 35.45? And you said there's how many? Times 2? Okay, so if we do that, that's going to be roughly what? 70.9 plus 137.33. So what is that? 208.2. 3. And the units are? Okay. So how am I going to use this? Who's going to help me out here? We'll do volunteer first, and then you'll be voluntold. So I'm going to put how many in the 1. That's right. 1 mole. Right? And then on top. Are we going to put that on top? Because doesn't it weigh 2.08? Okay. So that G/mole means grams per 1 mole, right? So that means I'm putting that 208 on top. That 208.23. Because that's how much it weighs. That's right. And look at it. It says how many grams. That's what we're looking for. We're looking for the number of grams. Why would I put 3 moles? Yeah, it's barium. It's one thing of barium chloride. Them together, one, right? That's a compound together. They're, okay. Okay, so the barium chloride is going to cancel out. Moles of barium chloride cancels out. And then all we have to do is multiply across. Who's going to do the math for me? How many sig figs? There's 3 sig figs. So you said 7, 70, 50, 74, 70.5. Oh, sorry. My bad. No, I don't. I was trying to listen to what you're saying. It's kind of hard to hear sometimes with the mask. See, I don't make bets when I know I'm going to lose. There's no 0? Okay. So 7.5, what? 0. So you said 7.496, right? And so we rounded up to 7.50. I got it. Okay, questions, concerns, cash, Kool-Aid. Okay, good. No questions. Keep moving forward. Everybody got this down? If not, you've taken a picture already? Somebody say, hey, wait. Okay. Okay, are you guys good? Okay, so recap. So we can basically go from moles to grams by using the molar mass, and we can go from grams to moles by using the molar mass. It just matters which way we decide to use it. And then we can also go from units or molecules, atoms, or whatever to moles, right? By using Avogadro's number. Okay, so we've kind of talked about stoichiometry, by using the chemical equation and looking at that molar ratio. Now you get to play with it for real, okay? So determine the mass in grams of 3.2 times 10 to the 22nd molecules of sulfur tetrafluoride. Okay, what am I going to start off with? With my given. What does sulfur tetrafluoride? S what? F4? Okay, yes, because there's only one sulfur and there's 4 fluorines, right? Okay, so what am I going to use? to get the mass. I'm going to use the periodic table. I am going to use the periodic table, but is that going to be the first thing that I'm going to use? What is the first thing that I'm going to use? Because I have molecules. I'm going to use avocado's number. Tell me about avocado's number. Okay, so I'm going to use, is that going to be on the top or on the bottom? Are you okay? I'm going to write down what you told me. So you're saying I have 6.022 times 10 to the 23rd. So Alyssa says it's on the bottom, right? Because I want to get rid of molecules, right? And that's going to be molecules. So it needs to be on the bottom. Okay. So this is molecules. No, because you don't want to make it moles because everybody gets that mistake. You have to write out molecules. I know it sucks. Of SF4. Okay, and so we have 1 mole on top. Okay, now I was hearing, I believe from Juan, is that right? Juan was saying, okay, so we also need to use the periodic table to get the molar mass. So what is the molar mass of sulfur? So sulfur is 32.06. So let's just say 32 for kicks and giggles. Okay, and the fluorine, how many fluorines do I have? 4 times 19. And that's going to equal 76. Altogether? Oh, just the 4 times 19. 108. 108. 32 plus 76. Okay, so grams per mole. Would I put G over G? Okay, so then I'm going to continue down here. So I have 1 mole on the bottom and 1 way up top. And that's grams. And that's of SF4. I know it looks like a 5. It's an S. Okay, so then I'm just going to multiply my tops and then divide it by that bottom. What do you guys get? Yep. Because I made a mistake. It should be SF4. Good eye, good eye. What did you guys get? 573.9. Okay, how many sig figs should I have? So then my answer should be 570 grams of SF4. Okay, so let's move forward. I heard wait. Okay, the next thing I want to talk about is percent composition. Percent composition is pretty simple. It's just the part over the whole, right? So if we're talking about a compound and we're only going to be talking about, let's say in the case of calcium fluoride, we're only going to be interested in the calcium, then it would be the part of the calcium over the whole of the compound. So for instance, calcium fluoride, what is the chemical formula for calcium fluoride? CaF2, calcium fluoride, calcium fluoride. Okay, so CaF2. So if we have calcium fluoride and we're interested in calcium, the percent of calcium in calcium fluoride, we're just going to take the mass of the calcium divided by the mass of the calcium fluoride. So what is the mass of calcium in calcium fluoride? 40, right? So calcium is 40. Fluoride, how many fluorides do we have? 2. 2 times 19. So that's 70. When we add it together, 78. .78 grams per mole. Yep. So we have 40 divided by 78 times 100. So where do we get 78 from again? By adding the mass of the calcium and the fluorine together. So what was the number you got? You said 51 point what? 51.28, so 51.3. Is that good? Percent. So then how much fluorine should I have? What would be the mass of fluorine? Subtracted from 100, right? 100 minus 51.3. Or I could do it the hard way, where I just take that 38 and divide it by 78. Same thing. Piece of cake? Yep, this is for calcium, so we put Ca for here. Yep, percent calcium. Okay, so now I have to go change my test because we're not where I want it to be. So we are stopping on chapter 7, right? Yes. This is going to be on this exam. Yes. Yes. So we're stopping at chapter 7. So all things up until chapter 7 are going to be, all the things that we talked about before are all fair game on the exam. Okay. Yeah, technically it's going to open today. Yes. It closes next Wednesday. Yeah. You're not going to be in class Wednesday, Thursday, and Friday, right? So technically you're in class Thursday. You guys are supposed to be here for your other class and everything, right? My class, you don't have to be there because you're going to give your presentation. You guys can come here and be here and give your presentation here if you want to, because there's a stable internet connection, right? Yeah, what was that? Yes, Tuesday will be the last day that you guys are going to be coming in person. Everything else is going to be done online. That means that you're responsible for showing up online. Any information that's going to be given to you, it's going to be given to you online. Okay? Okay. So Tuesday will be your last lab day. We have 2 labs to do, so come prepared. Okay? Okay, so you guys go ahead and take your 5-minute break. I'm going to talk to the other class, make sure they have everything under control. So, Kalinga, do you guys have any questions?
The only question that I have is that exam 2 is still open, correct? Because I take it tomorrow with Miss Norma.
Yes, it will still be open. I will adjust that right now. Yeah. Okay. And the upload will still be open as well too.
Okay, thank you.
Okay.
I have a question.
Yep.
For lab 6 and lab 7, are they going to be opened up by the night?
Lab 6 and lab 7. Remind me, lab 6 and lab 7 are which labs?
7 is copper chemistry.
Yes, we're gonna have those up and up for you guys to upload tonight. But all your labs are due next Friday, so you don't have to turn them in tonight. They're gonna be due next Friday.
So for tonight, what we need to turn in is a discussion, right?
So everything that you guys have left to do will be due next Friday. Again, everything that you guys have left to do will be due next Friday. Right? So you have time to get them done, even those discussions.
Okay.